We want to welcome you all to Weighing Your Options. Today's webinar, we have our presenters Keith Skidmore and Jeff White. They'll be detailing different products, solutions, including instrumentation that we have that is commonly used for weighing applications. We want to thank you for attending today's webinar. We are recording this event. Please use the chat feature. If you have questions, we will also try to address those questions at the end of the event during our FAQ. For today's event, we're going to cover a series of topics, including different introduction to what we have as far as solutions, how test and measurement is tied to weighing. It's not commonly something that people think about, but we use it quite frequently, and there's all kinds of different unique applications as well. Sensor types for weighing and lifting. We'll go into some weigh modules. Then we're going to detail some of the instrumentation options. There's many, but we'll hit some of the highlights there. And more complete solutions. We'll touch on options, including wireless and different accessories that are important for these types of systems. And then we'll get into some technical considerations, tips, from the engineering perspective, detail some interesting applications, and then finish it off with some do's and don'ts and some frequently asked questions. Again, please use the chat feature if you have questions, and we look forward to kicking things off. So let's get started.
All right, well, I'll jump in here. So introduction to interface weighing and lifting solutions. We'll kind of start with the background. When we are talking about weighing, the word scale comes up into play quite often, and load cells are truly at the heart of every scale system and make modern weight data possible. At Interface, we design, manufacture, and guarantee the highest performing load cells in the world. Although we are known primarily for our expertise in test and measurement, aerospace, automotive, medical, and a few other areas, we know our way around a scale. So where are these used? Weigh modules, floor scales, bench scales, truck and rail transport. How have we been involved? Past typically involved in the test and measurement side of things, but we're also incorporated in machines and rigs as components to a larger system. And currently, big in test and measurement, but complete weighing solutions as well. So weighing in product life cycles, look around you. Everything you see has been weighed on average 5 to 7 times before it ever gets to the consumer. Raw materials, in-process goods, final inspection, transportation, at the grocery store, on the side of the highway, at the local farmer's market, and when you're finally done with it. So everywhere from research and development to distribution, they are used in weighing individual parts or components. We'll do this in inventory checks, cycle counts, filling X number of pieces, using counting scales or checkwares, equipment and machines that measure weight during assembly and production. A lot of times you want a checkpoint before you get on to the next process. Weighing ingredients in food, food and bev, chemical, huge markets for weighing, batching out ingredients automatically. Weighing products during distribution, obviously truck scales, floor scales, forklift scales, rail scales, and during transportation. Next slide. So demands in weighing solutions. So sensors have certainly evolved since their inception back in the day. They've become more ruggedized. We have greater IP ratings, surviving wash-down applications, different materials, battling caustic ingredients. We get into hostile and high temperature environments. They become wireless, negating the need for long conduit runs, sometimes needing to break up conduit or tear apart a whole parking lot to get the load cell signal to the indicator. They've become submersible, tackling unique underwater, heavy washdown environments or areas subject to flooding. They become much easier to install due to thoughtful design, weigh module and mounting configurations. Continuous monitoring. We have integrated these sensors into the cloud. You could pull up scale data from anywhere in the world, and activating of components. So automatic weighing. So now we're in a time where the set it and forget it doesn't only apply to the rotisserie chicken. The combination of load cells and instrumentation or PLCs, your weighing process can easily be integrated and started by the press of a button. Next slide. So weighing systems. So here are the pieces that make up a scale or weighing system. It will consist of mounting hardware and of course a load cell. The mounting hardware will offer side checking, be able to compensate for thermal expansion, off-axis loading to a point. They typically come in sets of 3 or 4, but could be up to 12 or more. When you have more than one load cell in a scale or weighing system, a junction box is typically required. It will sum the cells and provide the instrument a millivolt signal, which will be converted from analog to digital and make it viewable on the display. From there, you can do all kinds of things that will be discussed today. And I'll let Keith talk about test and measurement ties to weighing.
All right. So while manufacturers everywhere are utilizing weight in their design, build, and supply, and defined weight is used in most product specifications, which requires accuracy in the measurement. Utilizing precision force sensing solutions and instrumentation allows product engineers and manufacturers of all types to collect data in real time. IoT-enabled weighing is becoming more and more popular, and that will allow access to the data anywhere in the world. Next slide, please. So Interface supplies highly accurate, reliable load cells and sensor technologies, and these can be used in weighing and scale solutions. Weighing and scales must be dependable and always provide correct data. Precision sensors are a critical part of this requirement. Interface is a leader in test and measurement solutions and very highly dependable and accurate load cells. Specific products geared towards weighing can be used for center of gravity measurements, batching in processes, inventory management, check weighing, sample testing. So all kinds of applications. Next, please. So interface load cells can measure across a wide range of force from 0.2 all the way up to 2 million pounds force or even more. Our weighing sensors combined with instrumentation use a variety of communication methods, including analog, digital, wireless, and cloud-based, to allow users to gather data in facility or remotely. And we can customize sensors to meet specifications for many different weighing use cases. Some examples of innovation in weighing would be facilities and cities are using connected force sensing trash receptacles for optimizing schedules of waste management. Got smart pallets where in factories and warehouses, they're actually sensing the force or the weight of items on the pallets as they're moved around. Silo weighing for inventory management. You can have automatic set points and automatic fills and basically management of the inventory in these silos. Next slide, please. So sensor types used in weighing and lifting. So interface manufactures load cells. Commonly, any kind of load cells could be used in a weighing or lifting application. One of the common load cells that we've sold for many years is our low profile that is actually commonly used by many of our customers under tank legs or in assemblies where they're weighing or lifting something. These have some advantages. They're very high accuracy load cells, very insensitive to side and extraneous loading. They're also wireless versions of these. So these are actually kind of a core product for interface. They're actually rather commonly used by some customers in weighing systems. Next slide, please. Just showing some more low profiles. We have some very highly spec'd, more accurate versions of these. Some that are more general purpose. Also some with integrated load buttons, as you can see there on the bottom picture. Next slide, please. Other types, stainless steel load cells for wash down, or if the tank or system is outside or exposed to weather or wash down. We have a wide variety of stainless options. Next slide, please. Beam load cells in scales and weighing systems. Beam load cells are very commonly used. Typically, it'd be 3 or 4 of these in the system, or if it's a weighing at a point, some apparatus might be attached to a single load cell, or you might have a bag or some kind of something hanging off the end of the load cell. A beam load cell works very well for that. Next slide, please. These are a very specific type of load cell used in scales It's a platform scale load cell, usually called a single point. A load cell like this designed to have a platform mounted to it, and then it's designed to have very little sensitivity to where the load is placed on that platform. So if you set right in the center of the platform or on the edge, you should get the same result. These examples actually have overload protection in both tension and compression, which is neat too. Say, why tension? Well, some of you were to pick it up by the scale, platform, it would potentially overload the load cell. So these are protected against that. Next slide, please. Load pins, we're seeing more and more applications where load pins are used in measurement. They're not quite as accurate or precise as other types of load cells, but they're very conveniently installed. A lot of systems have pin connections that could be replaced with load pins for measuring, say in legs or, in assemblies. They come in wireless versions, and these are always custom. So basically, if there's a pin connection, you can replace the existing pin with a load measuring pin to the exact dimensions of the existing system. Next, please. Also have load cells that are designed specifically, say, for lifting applications. A tension link load cell is certainly one. That load cell is easily installed in line with, say, a hook and a shackle, or cranes and lifting devices typically have the facility to install a tension link right in line with the line. These can also be wireless and can be used outdoors. They have very high IP ratings available. Next slide, please. This actually shows some wireless versions of these tension links. Again, why wireless? Well, if you're lifting something, especially if you're attaching to an existing system, it's going to be moving around, lifting overhead. It's super important sometimes to not have a wire that's kind of trailing around or in the way. So wireless gets rid of the wire. Very nice. Next slide, please. Also have load shackles. Again, lots of people are using shackles in lifting. This would be basically replacing a Crosby shackle with a load measuring version of it. These are available in either wired and wireless. They have very high safety factors. Again, with overhead lifting, there's always requirements. You definitely don't want to drop the load. So any kind of device you add in line with the weight must be rated for specific safe overload and ratings for failure. These can also be IP rated for outdoor use or even subsea use. We've used these. Next slide, please. So here's some more examples of these load shackles. This is somewhat to scale. You can see the little handheld display down there, and you see the little blue wireless module mounted on the end. So that big shackle to the right is actually a 2 million pound load shackle, if you can imagine that. You can imagine lifting or hoisting something valuable. It's important to monitor while you're doing that to make sure it's not hung up, or if the load changes during the lift, there's something going on, needs to be addressed, you can stop and review. Next slide, please. Flame proof, these are used in hazardous environments in some places where they might be exposed to flames. Next slide, please. Pillow block load cells. This is a product where the load cell is designed specifically to mount to a common pillow block bearing INA pillow blocks. And so imagine if you have rolls or rollers, something where you have product that might want to be weighed on those rollers, you could mount the roller bearings straight to the load cell. And also things with rolls, monitoring roll tension and, pressing like on a steel roller where they're actually pressing two rolls together. These kind of load cells are useful for things like that as well. Next slide, please. Weighing modules are very specific load cell systems, and I'll let Jeff talk about those.
Yeah, so here we go. A few different pictures of different weigh module types. You'll find there are a lot to choose from. They have their strengths and weaknesses, but more than likely, for any application, more than one is going to be able to tackle it. But some are going to be better for overload protection. Some will hold up better to shock loading. Some are better for mixers. Some are better for high accuracy. They all typically have some of the same features as far as upload and side load protection. A lot of them will allow for thermal expansion and contraction and make it a lot easier than mounting a bare load cell. Next slide. So here's one that we have. Some of the features here, it is all stainless. It is IP68. So this will hold up to a corrosive environment and partially wash down. This does have provides a very high accuracy. It's available in 3 envelope sizes with 13 different capacities. So pretty much we can meet any capacity and resolution that you are in need of. And this one does prevent accidental vessel lifting or sliding. Next slide. So the weight check is very good weight module as well. So capacity is anywhere from 2.5 to 50,000 pounds. Now that's per cell. So one thing I always like to point out is that if you have a 50K cell on a 4-module system, you have 200,000 pounds of capacity. These do offer high millivolt per volt outputs at 4 millivolt per volts, self-centering in all directions, has a safe side load of up to 400%. So this one would be good for mixing and thermal expansion and contraction. And it does have a standardized output, which is something worth talking about, because most of these, when you have more than one cell, are going to be all summed at a junction box. And we'll show you in a later slide what we need to do is called trimming. On floor scales, it's very common because you can see the load on each cell, but in a weigh module, it's very difficult to do that. So having a standardized output is very helpful in achieving a higher accuracy. Next slide. So here's just an example of some of the pieces there. So from top to bottom, so shoulder bolts, that's going to help with your side checking. Obviously, the top plate is going to be fixed to the foot of the understructure. Mounting holes on the bottom plate so that it can be mounted or bolted into the concrete. The rocker pin is going to make sure that the loading is going through the correct axis, and the rubber boot is there simply to keep away debris.
And maybe I'd like to expand on this a little bit too. Why weigh modules instead of just bolting a load cell straight into the system? Ideally, if you bolted everything together, it might work. But as the as the temperature changes, the tank expands and contracts. Or if you fill a tank, right, the legs bend a little bit. So there's all kinds of kind of extraneous loading going on. And so a weigh module actually allows that top plate to move relative to the load cell. So it sits on the rocker pin. It has stops to keep it from moving too far. But, a couple of millimeters, it can actually move side to side in all directions and can rotate a little bit. And so it allows the tank to kind of move as it's being loaded or as temperature changes. And it doesn't affect the readings nearly as much as it would if the load cells and everything were all rigidly mounted together.
Yeah, and one other thing is, all of these need to be on the same plane. And, if you don't have a perfect floor or all your legs aren't all the same height, typically these come with a shim kit as well to make sure that we're all going to be flat and level. Next slide. So load cell considerations. So a lot of the same considerations as far as what you might consider in test and measurement, but very much applied to weigh modules as well. So first is the IP rating. So ingress protection refers to how well it will hold up to the environment. The material, load cells will come in aluminum, steel, and stainless steel, and normally defined by the capacity in the load cell type. The environment is a consideration as well. The package size and profile height kind of go hand in hand, but it's certainly a consideration when it's being added to a system. Is there enough physical room for this to fit? And then extraneous loading. So kind of touched on that, but extraneous and eccentric loading and side loading, different weigh modules are better at taking these forces out of the measurement. Next slide. So how do we size it? How do we choose the correct one? Well, there's a pretty simple formula. So first, you're always going to want to know the dead load, or at least estimate it as best you can. So that is the vessel itself, the empty vessel. The live load is the material that you're weighting. So add those together, divide by the number of supports, however many legs. And then I always like to throw in a little bit of overload protection in case you're off, maybe 25%. One thing, and I always tell you, let me give you as much capacity as I can while still providing the resolution that you need, or get as close to it as you can. And the resolution defined is the smallest change in mechanical input, which provides a detectable change in the output signal. So what are you reading by? Is it going to be a 1%, a 1 pound increment, 5 pounds, 10 pounds? What is good enough for the customer? Other considerations, what is the material? Is there any shock loading going on? What is the environment? Is there any other attached conduit or fixtures or anything else that may cause a bind that need to be possibly removed or adjusted? Next slide. So just a couple good looking installations here. If you can get in on the front end of design, it's always a good idea to get with the tank manufacturer if possible. A 3-leg system will ensure equal loading at each point. Picture your stable milk stool versus a wobbly 4-legged chair. Also, consider how the system will be calibrated. And we'll touch on different calibration methods a little bit later, but test weights are always recommended, but substitution methods are very common in the field. If you can get with a tank designer, let them know, hey, it's a good idea to consider how we're going to either hang or attach test weights to this to be able to calibrate it. So the next few slides are different examples, kind of, this is certainly an existing one out there, but this conveyor weighing. So we can attach these to the legs at the bottom of a roller conveyor. This can actually be a static weighment, or we can grab this weighment in motion with algorithms in the electronics and indicator and controlling photo eyes and the roller conveyor itself. Next slide. A couple of these more just some ideas. So you can't really fill and discharge at the same time. This is also a way to do with belt scales. Belt scales we don't really touch on in this presentation, but I'll mention them briefly. They are a cost-effective way, but in my experience, sometimes a finicky solution to measure throughput. They offer rate in tons per hour and will give you accumulated total, but there are many variables on belt scales such as tension, conveyor angle, speed, material flow consistency. The advantages of this weigh hopper is isolated from the feed conveyor. The input conveyor can run continuously. The surge hopper serves as a buffer to smooth out demand. 2-spill feed is possible. Faster fill and higher throughput is possible. The only disadvantages of something like this are the overall height and the higher cost and sometimes complex controls and the mechanical arrangement. So we'll take it a step further in the next slide. So this is truly continuous weighing. So a single storage silo discharging into 2 weigh hoppers will allow for continuous process. As one is filling, the other is emptying, and there will be no interruption to the material on the flow discharge belt. Next couple slides are different examples of how to potentially mount these. They don't just need to be a weigh module fixed to the ground. We certainly have S-type cells that are good for tension, so these could be suspended. We can also go through the floor. So if the environment allows for it, going through the floor and having most of the load underneath the cell is often ideal. It'll help with any kind of tipping. And also we get to the, next slide here. So the next one would be above ground and the next one would be below the ground. And notice that the mixer is also closer to the center of gravity, but also below the load cells. And that'll help for tipping, stability, and making sure that a little bit higher accuracy there. And next slide, kind of the same idea here, but just note that some of these vessels, the center of gravity will change whether it's loaded or empty, and you want to make sure that it's always between the load cells. And again, when the weight is below the load cells, you can be confident that structure will not tip. Next slide. So one important piece, whenever you have more than one load cell, is a junction box. So this facilitates wiring. So you're going to bring all of your load cells in here and have one cable go back to the instrument. So they typically come in 4 or 8 channels. This allows for trimming so that, say on a floor scale, all of your corners will read the same. So no matter where the load is applied, you will get the same weighment. Next slide. Okay. So calibration methods. So I touched on these earlier. So there's a number of ways to calibrate a scale. Calibration weight is the recommended way to calibrate any scale if possible. Pretty much a verified solid lead block tied to the 1 kg standard through traceability, but not always possible. So another way to do that is an object from a calibrated scale. So if you have an object that you can weigh it on a calibrated scale, you can use that as a form of substitution. And then another way is substitution. So either you don't have test weights or you don't have enough test weights. Actually, most of the time it would be if you don't have enough test weights. So after you perform an initial calibration with the weights you have, you would remove those weights, replace them with products or material, whether it be water or whatever you're truly measuring, and then add the calibrations back to see if the scale is returning to the expected amount of weight. And then lastly, if none of those are feasible, a theoretical cal. So this can be done if you know the weight of the vessel, the volt output of the load cells, and you have a simulator or a voltmeter. This can be accomplished. And we do have a little write-up exactly how to perform this. Next slide.
All right, instrument choices. So all of these things we've been talking about thus far have had load cells in them with millivolts per volt outputs. So, obviously that doesn't do any good without something to read that signal. And that could be something simple like a display. It could be very complex like a controller or a data acquisition system managing a complex process. So here are some examples of types of instrumentation that are commonly used in weighing. Upper left, you see a weigh module, or I'm sorry, a weigh controller, quite fancy, lots of weighing functions. You also have just basic amplifiers and signal conditioners. A lot of times there's a PLC or something that just needs a 4 to 20 milliamp signal related to load, so we can do that. Sometimes just a basic display that shows pounds if somebody just wants a visual representation. But some of those displays can have analog or digital signals back to a PLC or controller. Some DIN rail mount amps can have little displays on them and take the 4 channels or whatever, however many channels in, and sum them together and give you a total plus the individual weight. So lots of different options. Moving on to the next slide. We're going to start with, these are the more basic options. You either have basic panel meters, and some of them have more functions than others, but basically they display load. Some of them will have set point relays, so you can set a relay to trip. So you can imagine you have a tank. If it goes below a certain weight, you could trip a relay that opens a valve and it starts to fill the tank. And then as the tank becomes closer to the target weight, it trips another relay and shuts the valve off. And then like a weight control would do that much more precisely with more functions around that. But a basic display with the relays can do that as well. Up top, you've got signal conditioners. They can be straight analog or analog and digital ones can have different outputs such as, Profibus, Modbus, Ethernet IP, Ethernet, EtherCAT, lots of different options there. Again, some of it's packaging. The one up in the upper left is in like a weatherproof box. 2 ones on the right are DIN rail mount that could go in a cabinet. So again, not one right answer, just depends on where you want the instrumentation to live. Next slide, please. These are some handheld displays. We actually have a number of customers who have some interest in just say walking around the plant and grabbing weights from certain things. Imagine they have some like gas cylinders around here and there, and they want to plug in, take a weight, and then walk away. You can do that with the portable handheld display. And if you have TEDs, it'll self calibrate every time you attach it to the new load cell. Next slide, please. Something like this is a little more fancy handheld display. It's battery powered, rechargeable battery, has ability to log to an SD card, and also can attach to our BlueDAC software. So pretty versatile. Again, if somebody's going to do something portable, this could be a good choice. Next slide. This is a digital junction box. And I was going to let Jeff talk about this one, actually.
Yeah, so this one's kind of an indicator and a junction box all in one. So this will actually take in 4 independent scales or individual load cells, depending on how you want your measurement. So if you wanted to see each cell individually, you could do it that way. And this will also sum it for you as if it were a scale. It does have quite a few outputs as well. So you come right into this and then go out to, say, a PLC with an analog output, 0 to 20 milliamp, 4 to 20, or have a voltage output as well. So kind of a neat little piece of equipment there. Next slide is our smart junction box. So we've looked into using this a few times, but so a smart junction box can read load cell data. So it actually takes in, it's kind of a step up from the last one. So it'll take in multiple cells. You can read those cells individually, and it also gives you on-screen diagnostics if you pair this with the correct instrument. You can see each cell's millivolt per volt value, and you can also see the weight value for each cell. What it'll also do is if a cell is damaged, in a typical scale system, if a load cell is unplugged or the voltage is way off, your display will dash out and you no longer have a scale. But what this will do is emulate one of those cells. So if you have a 4 load cell system and one goes bad, you can actually take an average of the other 3 cells and decide what that cell's output should be, and you're back up and running. So it provides uptime. It'll also send out an email in real time if it detects an error. So your scale provider could know that you have an error before you even realize. It is very helpful in troubleshooting. When your technician gets there to replace a cell, he'll already know which cell to go to and get in and out a lot quicker than he would otherwise. Next slide.
So data acquisition systems, many of our customers are putting together systems and they may want to set up a process. For example, with a customer who's going to be filling the gas or the fuel into rockets, right? They want to roll them around and manipulate them as the tanks fill. Well, that's going to go to some kind of a data acquisition system. They might want to use something like our BX8 to look at the data in real time and also have, say, an output to a control system that's controlling the movement or something. So a lot of our customers doing things more than just, say, weighing a tank, but actually a process. It may be, being controlled, and weight is one of the variables they're using as part of the control. We have a lot of options as far as these go. Next slide, please.
So
weighing instrumentation. Back to Jeff.
So typically referred to as indicators, but known by many names: scale head, weight display, controller, or simply where the numbers are. They're essentially the power source of the scale and can perform a multitude of functions. Some of them can sum up to 32 scales in one indicator, not recommended, but capable. A number of field bus options: Ethernet, IP, Profinet, Modbus. Pretty much talk to about anything, any PLC or PC on the market today. Next slide is a specific indicator that deserves its own slide. So this is the 1280 programmable weight indicator controller. Kind of rivals a PLC. The interface is very nice. It is full color, it is touch, and it has built-in Wi-Fi. You can pull this up, this information, and control it anywhere in the world. It even has a little Wi-Fi direct. So if your technician wanted to come up to it and talk to it on his cell phone and be able to calibrate a scale, many feet away from the indicator, that makes it easy for him to do as well. Some of the applications that you see this indicator used in would be truck in-out weighing, counting, batching, process control, in-motion check weighing. We can integrate thermometers, encoders, flow meters, timers. It is fully programmable. It is fully programmable and configurable. It kind of uses its own open source programming language similar to a C++. It integrates with that smart junction box that I mentioned earlier. We can translate the on-screen kind of instructions and all the words into multiple languages. And it has onboard 8 inputs and outputs, and fully expandable up to 24 more, and many set points as well.
Yeah, I can make a couple of comments on that too. I talked about the digital displays, which just have the basic relays. Something like this is much fancier. Maybe it'll have set points, but imagine if you shut the relay at a certain point, and then that still continues to flow a little bit. So you still get some product, for example. Something like this can actually learn and adjust the set point automatically, so you end up with the right answer. Or it can have a couple set points where it goes to a from a fast to a slow fill, and again kind of learns that, and takes the weight right up to the set point automatically.
So special options, wireless and accessories. So a lot of these have different communication protocols. Like I said earlier, a number of these indicators can talk to just about anything on the market. Factory setup. So depending on what kind of scale you get, a lot of times we can do a lot of that at the factory. We can calibrate it at the factory, but it is always recommended to calibrate once it's on site. Different bases, different assemblies, and we could do software, logging, graphing, and storage. Next slide.
So wireless, we mentioned it earlier. A lot of weighing systems are interesting, for a wireless setup. If it's up in the air, if it's moving, or it's just in a hazardous environment or trip hazard. If it's a system that's being installed kind of after the fact, adding weighing to something that already exists. A lot of times it's real nice to have wireless because you don't have the wires. Really simple as that. And then a lot of times too, the wireless stuff will be battery powered if there's no local power available. But one nice feature is you can definitely hardwire the transmitters to power. So a lot of times there is power available, like say at the system. It's just the data you want transmitted wirelessly. So many of these systems can be hardwired for power, and then the data wireless. And then there's a whole ecosystem of products that work with this. So you can have, again, outputs to PLCs. You can have digital displays. You can have printers. You can have handheld displays. You have log to software. You can do all that simultaneously. So one signal can be sent or received by any number of different devices. Next, please. Say we talked about this earlier a little bit, but say a weigh module kind of rolls a lot of the mounting into an assembly. But say you're using an S-type load cell or a beam load cell, or even one of our low profiles, so very high precision lifting, you might use a low profile load cell with rod end bearings and clevises mounted in it. Again, load buttons, top and bottom plates, all these things can be used to make a system. Again, we offer trimmed output, which is matching the load cells to have the same output. Different cable lengths and long cable runs and things we can accommodate. Millivolt per volt simulators are very useful. Basically dial in a millivolt per volt value, and that's the same as putting a load on the load cell. So you can use something like that to dial through some loads when you're setting up a display. Very useful for troubleshooting too. Sometimes it's hard or awkward to add a lot of weight into a system, take it back out, and do that a bunch of times. Whereas a simulator, you can kind of do that with a dial, so you can dial through the whole full scale and back to zero, back and forth. You can quickly run around and check, see each load cell, and see if the cable's bad, or if that channel input into the signal box is bad or whatever. So simulators are super useful. And then closures and cases. We do a lot of custom systems. Again, if you say you want a panel meter, want it in a box, maybe you want a totalizer and a weight display and a flow meter attached. We could do a box that had 3 displays in it. Could be battery powered, could have wireless inputs and outputs. Just depends. The world is really wide open as far as what we can do to customize things. Next slide, please.
All right, some technical considerations and engineering tips. So one thing to take into consideration, you're all probably familiar with your excitation and signal, but on longer runs, which is very typical in a scale setup, sense wires come into play. Sense wires are used in longer cable runs and sense the load cell voltage. If there is a drop in voltage, the indicator will adjust the excitation. So anything over 50 feet, you might see some drift. You might see some just some funky numbers on the scale. So just know that, before you start troubleshooting any further, maybe swap your 4-wire cable to a 6-wire cable. Next. So load cell trimming, I kind of touched on this earlier. One of the nice features of the weight check is that we have matched outputs, but typically your cells are going to be plus or minus a few decimal points, and it's going to be important that they are all matched. So, there's 2 ways to do it. You can do excitation or signal trim, pretty much, determine how much voltage is going to the scale or determine how much signal is coming back. And within the junction box, there's potentiometers in there to kind of play with how much power is going back or forth. And essentially you want them all to be matched. So here's the example of your floor scale. If you were to walk across the corners, you want to make sure that you weigh exactly the same amount, no matter where the load is applied on the scale. Next slide. So troubleshooting. So really there's 4 places to check. The problem is going to be in the instrument, the load cells, the junction box, or the cable. First thing is physical inspection. How does it all look? Is it rusty, corroded, oxidized? When looking at the load cell specifically, look at the gauged area. Is there holes in the potting? Check the cable entrance. Is it bent, cracked, distorted? Look at the cable itself. Cuts, nicks, crimps, abrasions. Water loves to be wicked up through the cable. As Keith was mentioning before, using a simulator will help you determine if the issue is in the indicator. That will pretty much tell you, hey, if you use a simulator, my scale is good. And if you're still experiencing issues, you know that the problem is within the indicator. Now, if you hook up your simulator and your indicator and all is well, then you start looking at the load cells. And here are 4 things to check for: the physical inspection of the cell, and then the zero balance. So that's probably the first one to start with, just to see if the cell itself has been physically distorted due to overload, shock load, or fatigue. And this can be done with a voltmeter. And then your bridge resistance and your resistance to ground, those can also be checked with multimeters or megometers. And if all else fails, take the cell out and let it dry out. A lot of times if a cell is sent back for evaluation, we may hook it up here and say all is well. Well, the time it took you to package it up and ship it to us, the cell was dried out, and away we can go.
Yeah, I think a final comment too, mechanical, assuming the system works, you can assume it should continue working. And if so, then maybe one of these issues, but also look for mechanical, parallel load pass. Imagine if somebody jacked up one leg a little bit to do something and they forgot to remove the jack, right? Or say something's binding, something shifts a little bit, and now you've got some rubbing or something. So there's mechanical, things to be checked too. And a lot of times that might be the issue. Next, please. So we're going to just go over a few applications briefly. They're kind of conceptual, but we have a lot of customers who are using our load cells to weigh things in process or adding weight or force measurement to systems like a vehicle. Imagine any kind of truck. It could be interesting to weigh the product that's in the truck, in the bed, or in the container. It can be done in many different ways. Imagine a manufacturer of trucks might want to add weighing into the system. Might be a custom load cell, or could implement something like a beam load cell between the mounting points of the, to the bed of the truck, for example. Next slide. Airplane weighing. A lot of airplane weighing happens in the world, and it turns out a lot of it wants to be wireless. We've sold a lot of weighing systems with wireless load cells. Some load cells, or I should say airplanes, have jack points. There are various reasons you might want to weigh an airplane. One would be just to see how much it weighs, or look at the center of gravity, the weight distribution. Also during service, they need to jack it up to, say, a neutral position. So you imagine the wings have a lot of stress in the skin. If it's just sitting there on the ground, they may have to jack the wings up so that they're in sort of a neutral position, say to take the rivets out to remove the skin, for example. So any of those things are possible. This is a system using our WTS wireless system attached to low profile load cells. The customer implemented jacks and fixtures that attach to the jack points on the aircraft. There's custom software that shows each lift point, and they're actually live readings of load showing either red, green, or orange, depending on if the lift is in target. Imagine if you're lifting up real, with too much force in one place and not so much in the others, you could punch a hole in the aircraft or tear the wing off or something. So very important. And, imagine things like this could be weighing trucks, could be rail cars, could be any number of things that want to be weighed or lifted to weigh them. Next slide. So crane capacity verification. We have a lot of customers have lifting devices and things, and they have some interest in, understanding whether they're lifting or weighing accurately during the lift, right? And so the nice thing about something like this is you can install something like a tension link or, any of our load cells, a low profile load cell with clevises and rod ends, or a tension link, or one of those shackles we showed. Just kind of depends on the level of accuracy required. But you lift anything up, use the inline sensor as a reference. So you don't have to have a known weight. You just lift up something, as it shows a pallet with some boxes on it. And you can then compare the reading from the tension link to the instrumentation that's actually attached to the crane, for example, and use it to verify the system. Again, any number of types of instrumentation could be used with that. Could be as simple as a handheld display. Could be logging to software, could create a report, a calibration report, if you will. Again, wireless makes a lot of sense on these kind of systems, especially if they're lifting and moving around high up in the air. Next slide, please. We worked with a customer who is making drones. The drones are designed for package delivery, and they want to monitor not only the weight of the packages being lifted, but also the weight distribution of the packages. And interesting, just as they tune their flight algorithms to understand, what happens if the CG of the package moves around during flight or shifts. Also, obviously, make sure they don't try to pick something up that's too heavy. They can also estimate, things like fuel economy or range, depending on how much weight is in the system. So these were WMC sealed load cells. They had to be weatherproof, and they were mounted in the at the lift points, and 4 of them going back to the system. Next slide, please. Cattle weighing. We actually have customers doing this as we speak, but there are systems you can buy, obviously, that would do this as a turnkey solution. But a lot of customers, a lot of people have systems already in place. They may want to add a weighing capability, and so you can imagine mounting, say, a fake floor in something like this, supported by load cells. And as the cattle walk in, you can take their weight. Simple as that. Again, you might just want a display. Typically, something like this, the farmer, rancher just wants to be able to have a look at it and see what they weigh and, move the cow back out. So not super sophisticated. Lots of ways it can be done this. The floor could also be, say, suspended by a chains in each corner with an S or a beam type load cell. And some stops so it didn't swing around too much and disturb the livestock.
It's also important to select the right instrument for this, because a lot of times we have filtering in there. As you might expect, these animals don't necessarily want to be where you're telling them to go, so they may be bumping around. So you want to be able to make sure you get a stable weight on there, so your numbers aren't jumping all over the place.
Yeah, good point. Snack weighing. We have a lot of load cells that are going into packaging machines. A lot of these are OEM applications, but it could be somebody has a machine and they just want to add some weighing into the process that's not already implemented. This is an example of a SPI load cell. One load cell mounted under each little platform, and then the product is dispensed into, say, a bag that's sitting on the platform, and it's filled by weight. Something like this could have a simple analog amplifier attached to it that sends a signal to a PLC that then controls, say, movement of the machine and the filling process. Next slide. Let Jeff talk about this one.
Yeah, so lifting heavy objects, crane scales. So it's important, probably the takeaway from this one is to be sure that anything overhead is that we have a high overload protection, and typically a 5-to-1 safety overload protection before it will structurally fail. So very important when you're weighing over people's heads. Also, a lot of wireless applications. pair that with a handheld indicator. Make sure you know what you're picking up, so you're not going to hurt the crane, and you're not going to drop it while it's suspended in the air.
One point to mention too is a lot of our customers are manufacturing or moving, very expensive items. And so one of the considerations when something's being moved would be to monitor, say, tension as you're lifting it, either in single point or multiple points. And reason for that could be if it gets hung up, or say it's strapped down and somebody forgets to remove the straps, or whatever. If you're lifting something, it should be a profile of the forces as that part is lifted and moved. And if they go out of out of range, you can stop, analyze, review, make sure nothing's going to be damaged. Very important measure moving a satellite or something that's very valuable, one-off. Very important to monitor all stages of the process as you're moving something like that.
And lastly, if you're doing, as opposed to a single point here, if you're lifting a container, say you have lifting it at 4 points, it'll also give you the center of gravity to make sure it is loaded correctly, so that when you are picking it up, it isn't going to slosh around or put too much load on one corner.
Oh, tank weighing. We've talked about tank weighing. We have certain customers who have been interested in actually looking at the centered gravity, or what that would tell you would be, say, the distribution of the contents in the tank. And it could be for something that, say, tends to clump or gather at one side. It could be for safety, could be wind loading. Do you know if this thing's getting ready to start tipping over or not, or things like that. And so you could weigh, but as Jeff pointed out earlier, depending on what you do with those signals, you can either look at each one individually, or you can just sum them. So if you look at them individually, then you can actually sum them afterwards, but have an individual weigh. And then you have set points to say if one gets too heavy, you do something, you stop, whatever, or you can actually calculate the center of gravity on the fly. And like in a tank, you want it to be like straight down through the middle. If it starts to shift, something's, maybe the product's accumulating on one side of the tank, and it's time to get in there and clean it out, for example. Fruit weighing. This is kind of an interesting one. You imagine you can have little scales on each of these conveyor points. More likely you might have an application where you're moving something with a conveyor like this, where the customer wants to implement some kind of a measurement into the actual platform. And so that could be a custom load cell. It could be every point has a little sensor that manages these products. As again, it gets loaded, they may be weighing and accumulating how many pounds worth of product was collected through the day. It could be making sure you're not putting underfilled bins on, whatever. But lots of reasons this, someone might want to measure a product, and it doesn't have to be just a scale. It could be, measurement built in to the system. That could be a custom load cell that's completely custom for this application. It could be something off the shelf. Just depends what works. Next slide.
So some of the do's and don'ts when weighing or lifting. So do consult interface. Especially if you're not so super familiar, we will be happy to help you choose the right equipment, the load cells, the weigh modules, instrumentation, and tell you the questions to ask your customer. Again, some of the questions that need to be asked: the live load, the dead load, the number of supports, washdown, material being used, temperature, hazardous environment, type of vessel, tension or compression, what is attached to this, mixers, shakers, rigid conduit piping, will there be shock loading? And then always find out, what kind of increment do they need to weigh by? And then what are you doing with this information? Is it going to be a part of a process? Are we printing a ticket? Are we logging it? Or are we simply viewing it? And then also, consider calibration procedures. Don't oversize or undersize your scale. I always give the example, give as much capacity as you can while achieving the resolution that you need. Don't cut your load cell cable. We've seen it, probably too often, where the cable is cut right at the cell, and there's truly nothing that you can do with that other than throw it away and get a new one. Don't ignore the manual. There are a lot of tips and tricks as far as installation, configurations, how the cells and weigh modules should be oriented. And don't do what this person did in the picture. Look at it closely, but this cell isn't going to give you too much output. You're pretty much just pushing on one end of it, but the load is not appropriately applied. So next slide. So some of the frequently asked questions that we receive here. What is the accuracy? So a question regularly asked but cannot always be answered without knowing more. The true answer as to many of these questions is it depends. It depends on the capacity, the environment, the system design, and other factors. Typically, though, you can expect around 0.02% accuracy. Can load cells be used outside? Yes, if the correct material and IP rating or seal is selected. How long can the cable run be? So this typically refers to the home run cable. It can be quite a ways. Consider your 4 or 6 wire load cell cable. I've seen 150 meters with 6 wire. And then also we can customize the cable length coming off of the cell. How many load cells should I use? Well, it depends on how many legs you should use. If you're at the beginning stages, one thought is always that 3-legged stable milk stool compared to the wobbly 4-legged structure. Sometimes you're going to do 8 or more, but just consider that all of those need to be on the same plane, and getting 8 weigh modules and load cells on the same plane can be difficult. Do I need a summing box? Well, if you have more than one load cell, it is recommended. Can you twist the wires together? Sure, but your accuracy will most likely be reduced as you're not going to have matched outputs. Should I sum the cells individually or use a summing box? So it kind of depends. Are you interested in the weight of each load cell, or do you just want the combined total? What instrument should I use? So there are so many out there, and the true answer is that it depends, and then you have to ask the right questions. The first question I always ask is, what do you want to do with the data? Why is this weight value important to you? Are you sending it to a PLC, printing it out, just viewing it? Do I need to calibrate my scale once it is delivered? It is strongly recommended. Some scale systems we can offer factory calibration, but who knows what happens between here and there. How often do I need to recalibrate my system? Again, it depends. How often do you use your scale? How important are the values to you? You could do bi-weekly, once a year, but quarterly is probably most common. Also, not a bad idea to, if possible in your scale system, is to purchase a verification test weight. Every morning, just throw that weight on there and see if you need a service company to come out. I need to weigh by 1 pound. Is this possible? Again, it depends. Like I said before, 20,000 divisions is a good rule of thumb. So if your capacity is above 20,000 pounds, you may not be able to achieve that 1 pound resolution. So choosing interface.
Well, we appreciate everyone considering interface. We're the trusted leader in force measurement solutions, also do a lot of weighing, and we have a lot of expertise and options in that area. Next slide. Why interface? Why not? Lots of experience, and we have a wide assortment of products to offer. On to Jeff.
Yeah, so I think a couple of the takeaways, it's just important to know that these applications exist and that interface has solutions. For the reps and distributors out there, you're probably already working with customers that are in need of solutions that we can offer. And this is a whole new market that you could potentially add to your portfolio. And for the value customers tuning in, if you're not working with us already, you may be exhausting time searching for other vendors when it might be easier to come to us, consolidate with an existing trusted partner. Simply put, if you need to weigh something, we have a way to do it.
Thank you, Jeff. Thank you, Keith. That was a great conversation, brought a lot of insight and a lot of information. The good news is we recorded this presentation, so we will make this available on our YouTube channel. We will be sending it out to all registered attendees, and we will also make sure that you can find this online in our blogs and our website. I think the takeaway here is if you have questions, if you're looking at a unique application, you are questioning whether or not you've got the right instrumentation set up, contact us. We're here to help. And with that, I don't see any questions, so I will leave it here as you finish perfectly on time. Thank you, guys. And everyone, please have a great day.
Thanks for coming, people.
Thank you.